Let's look at the traditional configuration of Eigrp. So here we have a few routers, router 1, router 2, and router 3. So they are going to communicate using Eigrp as their routing protocol. So kita dah create satu network here, 192.168.1.1 untuk interface ni. So 1.0 lah network. And between router 1 and router 2, the subnet is 10.1.12, and between router 2 and 3, the subnet mask is 10.1.23, while the next subnet is 172.16.3/24. So here, let's configure basic Eigrp using the traditional method. So the keyword is router and Eigrp, and the next value is the AS number. So this AS number needs to match in order for us to form neighbor relationship. So let's say we give it 10 AS number, right? So I've already do show IP route to look at the individual interface that is connected to R1. So we have E01 facing the LAN with the IP 192.168.1.1, and the interface 0/0 facing the next router is 10.1.12.1. So this helps in router configuration. So the normal router configuration is when we want to make sure the Eigrp advertises or participate in the Eigrp for this particular network, we use the keyword network. So the keyword network simply means that whatever network that is stated in this statement, if you have an interface in that particular network, please participate in the Eigrp. So we have two interfaces, one in the network 192.168.1.1, 1.0, and 10.1.1.2.1.212, and we want both of them to participate in Eigrp. So we need to create the network statement for both networks. So the traditional way is network and then the network address 1.0, and then the wildcard mask. So let's say the wildcard mask, the subnet mask is 255.255.255.0 or /24. So you want to subtract 255.255.255.255 to the subnet mask, which is 255.255.255.0. So that makes the wildcard mask as 0.0.0.3. Okay, so this will simply say, so if you have a network 192.168.1.0 and the wildcard mask is 0.0.0.3, then the network range will be 1.0 until 1.255. Okay, and if we have a interface in that network, in this example we do, which is the interface 192.168.1.1, then that particular network will participate in the Eigrp. Therefore, the router will advertise this network to other router. Okay, so also we can do another way in Cisco where we use network and then the individual interface IP. So in the individual interface that we have not done the network statement on is the E0/0, and its IP is 10.1.1.2.1. Okay, so in this case, we want to have the exact match of this IP address. So we use the quad 0 wildcard mask, which is 0.0.0.0. So we have this feature in Cisco where the router, when we receive the network statement using quad 0, it will automatically calculate the network address of this interface 12.1 that we have configured in the interface command. So whatever subnet mask that is given in the interface command, it will take that subnet mask and calculate the network. So the whole network of whatever we have configured here, for example, I have configured it to be /30. Okay, so that particular network will be participating in Eigrp. Okay, and it turns out definitely we have the interface in that particular network. All right. Okay, so that's it for the basic configuration. Right. Let's see if this work on router 2. If I use a different AS number. Okay, so now I'm going to do both of the methods using wildcard mask and also quad 0 as well. So the network facing the router 1 is 10.1.12.0, and the wildcard mask will be 255 minus 252.3 lah. And the quad 0 method is 10.1.23.1.0.0.0. Okay, let me check. All right, I have done a mistake here. 192.168.1.0, and it's not 0.0.0.3. It's network 192.168.1.0 and 0.0.0.255. Okay, so by right, it should form neighbor relationship, but it's not forming. So I would assume that this is because the AS number is different. So I'm going to configure no router Eigrp 20, router Eigrp 10. Okay, I'm going to do the network statements again. That's for network 23. And this is for network 12.0. So immediately the neighbor relationship is up. Okay, let's do for router 3 as well. So this time, I know that the AS number needs to match, and I'm going to do the quad 0 for both interfaces. So immediately it goes up. Okay, so and so that's already a successful neighbor formation between the 3 routers. Okay, so this was the routing table previously, this one. Now let's look at the routing table for R1 after the configuration of Eigrp. So we have the routing table, some additional routes. So we are knowing the network 192.168.1 and 10.1.12.1. So now we have additional networks that we know, which are 10.1.23, which is the network here. This is a remote network. It's not directly connected to R1. So now by Eigrp, we learn this route, okay, through D. D, I guess it stands for dual, okay, because Eigrp uses the dual algorithm for figuring out the best path, right? So next we know the network 172.16.3, okay, which is this network. Okay, so by right, all the routers should have knowledge of all the other remote routes via Eigrp. Okay. So what it means here is basically it has a route to go to 172.16.3 and it's via Ethernet 0/1, and the AD is 90 and the metric is 307200. Okay, so the metric is what we've discussed. Basically the K1, K2, K3, K4, K5. But basically K1 and K3 only is 1, which is the bandwidth and delay. All right, so it's based on Ethernet interfaces. Maybe you find in the your content, the value, the metric will be less, which is 3072, because it uses the gigabit Ethernet. Okay, so plus 2 zeros here is because Ethernet is 100 times slower lah, than the gigabit Ethernet. Okay, so what else can we look at on the basic configuration of EIGRP? So first, we can look at because EIGRP has 3 data structure. We've looked at the first one, which is the routing table. Okay, basically before putting routes inside the routing table, it actually has a way of figuring out which is the best path. That is using the dual algorithm, and this algorithm will put a backup path or calculate a backup path. Okay, and they put the backup path or all the available path the topology table. So let's look at the topology table now. Okay, so the topology table contains all the possible particular network. Okay, so P here stands for passive. When we say passive, it means that the router is not looking for a path to a particular network. That means it's already converged, right? So it has 1, 2, 3, 4 networks that it knows the way to go to. So router doer has a knowledge of how to go to these networks. So the first network is 10.1.12 /30. So one successor means is the best path, and FD stands for feasible distance. So the feasible distance for R2 to go to this network is 281,600. Okay, so we are at router 2 and 10.1.12 is this network. Okay, so for router 2 to go to this network, the feasible distance is 281,600. And it's actually there is only one way to go there, and it's directly connected to router 2's Ethernet 0/0. Next, we have 10.1.23, and we also have one successor. There's only one best path to go to this network. And the feasible distance is also this, right? Because it's equal, both are Ethernet, right? So, and it's directly connected means there's only one hop to this network. So, the feasible distance is equal. So now let's look at the remote networks, which is 192.168.1, and it is this network. Okay, so it needs 1 hop and 2 hops to go to this network, and the feasible distance is 307,200. Okay, so the feasible distance is here. Okay, and this is the reported distance. Okay, so the reported distance is the distance from the router reporting the distance to router 2. Okay, so since it's coming from Ethernet 0/0 of router 2, that means the adjacent router is router 1. And router 1 is saying, I have the way to reach 192.168.1/.0. Okay, and the distance from me is 281,600. Okay, which is the distance for Ethernet interface lah. And then you add the interface, the distance from router 1 to this network. The way from router 1 to router 2, which is has its own metric. So you add those two together, you will get 307,200. Is the feasible distance of 192.168.1.0 from router 2. And the best path is via router 1. So same goes to the remote network 172.16.3.0. So it has one successor. There is only one best path, and the feasible distance is this 307,200, and the reported distance from the router facing the Ethernet 0/1, which is router 3, is 281,600. So that's how the router makes a decision. So in this case, there is only one path to all the possible networks because we made it so the topology is like this. Okay, but it will be different if we have an alternative route or an alternative path between the networks. So what if we have an alternative path? For example, here I changed the topology to add the serial interfaces from router 1 to router 3. So let's look at what happens to the topology table if there are alternative paths. So now, from the point of view of router 3, there is more than one way to reach network 10.1.12.0/30. So you can reach it via 10.1.23, which is router 2. Okay, and the feasible distance is 307,200, and the reported distance from this router, which is router 2, is 281,600. Or you can reach via the serial interface, which is 10.1.13, and the feasible distance will be 219,5456. And the reported distance is again the same. Okay, because it's reporting the network here. The distance is for the Ethernet interconnection. Also, we have more than one way to reach 192.168.1 here, which is basically either from here using the Ethernet or using the serial. So again, based on the calculation, the feasible distance is 332800, which is via the Ethernet. Okay, you go here to reach 192.168. Okay, but the topology table basically shows all the possible paths, and from the two paths, it will be selecting the feasible distance that is the lowest here, for example. Next, let's look at another data structure in Eigrp, which is the neighbor table. So, Eigrp neighbors. So, router 3 has two neighbors, which is 10.1.13, which is router 1. So, via the interface serial, and we see that here we have a hold time that we've discussed before. So let's say I do this show command repeatedly. You see that the hold time is decreasing, right? So from 14 become 13 to 12 to 11 and 10. So later on, it will reset itself when it receives a hello from the neighbors, right? So this is just to view the neighbors and also to understand that this whole time is basically 3 times the hello from the neighbor, and the whole time is basically coming from the neighbor, which is 10.1.13.1. When it says my whole time is 15, so it's saying to router 3 that I need to wait until the end of 15 seconds before I deem this neighbor as down, right? So the same goes for 23. So by default, the hello time is 5. So router 3 will send a hello every 5 seconds. And then the whole time for each neighbor, okay, will be different if we set the whole time differently. But by default, it is 15 seconds. So that means the neighbor, which is 10.1. router 1, will need for the router 3 to wait for 15 seconds and counting until it deems this neighbor as down. Okay, so that's the use of the hello time and also hold time. So this is a little bit different than OSPF's dead interval, in which dead interval is for the router 3, the local router, to wait the amount of time before deeming a particular route can be purged. Some other basic show commands for the router is show IP Eigrp interfaces. Okay, so here we just look at the interface, but there's another command where we use Eigrp interfaces detail to look at the individual interfaces, right? So this is where you verify the hello interval and hold time for each of the interfaces that you have. Okay, so the hello and the hold time can be configured individually. So they do not have to match, okay, as opposed to where OSPF, we need them to match with each other. Okay, so another thing that I forgot to mention is the topology table contains the best and the backup path. So if our topology contains more than 2 routes, okay, it might be in the command show IP Eigrp topology all links. Right. So at the moment, our topology is a simple one. So the contents of topology and topology all links will be the same. But if we have more than 2 alternative paths, when we use the command topology all links, it will contain all. But if we use only the keyword topology, it will contain the successor and also the feasible successor, which is the best backup. So in this case, because it only has 2, right? So in the topology, if you use the topology, it's the same actually. Okay. In the topology, it only shows the best, which is this one, and the backup, which is the serial one. Okay. But in the topology all links, if we have more than 2, then it's going to list down all the possible paths, including the successor and the feasible successor. Okay, so next let's discuss about Eigrp stub. So in this topology, where we have a feasible successor, so that means, for example, if I am router 3 and I want to go to 10.1.12 network, I have 2 paths, one from Ethernet and one from serial. So that means if Ethernet path is down, it can go to the alternate path or the feasible successor path. So it can go through serial 1. But let's say serial 1 is not there or is not eligible to be a feasible successor. So that means it will not be in the topology table. So what happens is router 3 will send a query to its downstream routers. So for example, it send a query to the router 1, right? So it will ask router 1 whether it has the path to this network. So let's say it does not have, because router 1 is supposed to relay this query to downstream routers, so it's not connected to any other router. So it might not have the path to the network that it is being queried about. So in this case, we want to suppress any query messages from the Eigrp routers to save bandwidth and to save resources. So we can configure R1 to be a stub router. Okay, so this is assuming that there are no alternative path and R1 is only connected to router 2. All right. So in this case, it will not have any answer to an alternative way. Okay. For example, here this is supposed to be an alternative way using the serial. But let's say this is back to the original topology. We don't have the serial. Then R1 will not have any other path. Okay. So we can suppress the query messages because it's not sending to another router by using the Eigrp stub. Okay, so let's do this from the point of view of router 1. We want to configure R1 as a stub router. Okay, so right now, let's look at R2 routing table. Okay, so right now it has the path to 192.168.1. Okay, because it's directly connected to R1, right? Okay, so now we want to configure R1 to be a stub router. All right, so in the lab sheet, the configuration might only cover just one functionality of the stub routing configuration. Okay, but first thing first, R1 also has an interface to a LAN. All right, so it's not connected to any other router in that manner. So it only has a connection to router 2 and router 3. Therefore, we can do interface E0/1. Sorry, let's see, router Eigrp 10 passive interface E0/1. So what this does is, it still is advertising the network 192.168.1, but router 1 will not be sending any hello messages to the interface E01 because there's no point, there's no router connected to this particular interface. To stop. So the command will be Eigrp stub. So now you see it changes its neighbor relationship after we configured the Eigrp stub. So let's look at what happens to router 2. Does it still see the network 192.168.1? So it seems that it does. It can view the network 192.168.1.0. So what does the stub configuration do? Let's use the IP Eigrp neighbor detail, right? So the neighbor here is 10.12, 10.1.12.1, right? So we can see that this neighbor, which is router 1, is configured to be a stub. So it's saying stop peer advertising, and so it's only advertising connected and summary routes. So basically network 192.168.1.0 is directly connected to router 1. So that's why it is still continuing to advertise to router 2. So you can see here the neighbor 10.1.23, which is router 3, is not configured as stub. So this is the difference. Now let's look at what other configuration that we can do in the stub. So we get back to the Eigrp stub on router 1. So basically we can use the question mark to look at what are the available commands. So instead of just doing the default Eigrp stub, where it's going to advertise connected routes and also summary routes. So in our case, we don't have any summary routes, right? So it's going to advertise just the connected networks, which is the 192.168.1.1. So we can also do connected only. That means it's not going to advertise the summary routes. Or we can use a leak map. So this allows for dynamic prefixes based on the leak map. So a leak map is basically like a filter. So let's say, for example, we want to configure R1 as a stub because we do not want to advertise any networks to the other router in the AS. However, let's say after this, we are going to connect router 1 to another router. and they have routes from other networks, and we want to give or advertise only a certain route from all the routes that is available from that particular router. So we can introduce, let's say, just one network, introduce that network or advertise that network into the AS using this leak map. So we would do an access list, and then put that access list inside this leak map, such that the stub router will not advertise other networks. Only those inside the leak map will be sent to the other routers. Okay. All right. So let's say that one will do maybe later. But let's say we do receive only option. So again, it will reset the neighbor relationship. So let's look at what happens if we do the stub receive only. So it's saying receive only peer advertising, no routes. And if we do an show IP route, we will not be receiving any advertisement for the network 192.168.1.1. So therefore, basically R1 is only receiving advertisements from other routers, but it is not advertising its own network. Let's put that back to stop. Okay. So next we have also redistributed routes. So that's another option. Or we can have to router one to distribute only static routes if we have configured any static or default routes. And also if we want to constrict R1 to only advertise summary routes. So those are the options that are available when we want to configure Eigrp stub. So basically, the stub is to suppress the advertisements into the AS to other routers, simply because sometimes in the topology, we do not need to advertise, such as router 1 being not connected to other routers, is only connected to a LAN. Okay, next, let's look at Eigrp's unique feature, which is unequal cost load balancing. So in OSPF, we have seen that it is able to take a load balancing route, which means if there are two paths that has the same metric, then OSPF will take those two paths into its routing table. So you are able to do load balancing on both of these paths. However, the paths need to have the same metric. For Eigrp, we are able to take two different paths that have unequal cost and put it inside the routing table. Okay, so in this example, we have the topology where router 3 has two possible paths to go to the network 192.168.1.0. So one is through router 2 and the other is directly to router 1. So when we take a look at the R3 routing table, we see that the selected path is on Ethernet 0/0 or via router 2. So actually we can see the possible path through the topology table. Okay, so the path to network 192.168.1.0 has one successor, which is the best path. This is through Ethernet 0/0. Okay, and this is the feasible successor, which is via serial 1/0. So why this is a feasible successor is because the reported distance of this path is less than the feasible distance of the successor. So it satisfies the feasibility condition. So now by default is going to take equal cost load balancing. So when we have two paths that is not of the same metric, it's only going to take the best one or the one with the less cost. All right. So now we want to make unequal cost load balancing. we use the variance variable. What we do is we see how big the difference between the feasible successes, feasible distance, and the current successes feasible distance. So we can do on a calculator, for example, two one nine 5456 divided by 307,200. Okay. So that makes about 7.14, but the variance needs to be in integer. So we take the closest bigger number, which is 8. So let's try this. Router Eigrp 10, variance 8. So what happens to the routing table? Now you will see that we will have two paths to the network 192.168.1.0. So this is what is happening with unequal cost load balancing.